Hello, welcome to Physics 101, where we would be solving physics problems together. In our first example, the electric fan is turned off and the angular velocity of the fan decreases uniformly from 500 revs per minute to 200 revs per minute in a duration of 4 seconds. We are tasked to find two variables. In task A, we are to find the angular acceleration in rev per second square and the number of revolutions made by the motor in the 4-second interval. While in task B, we are asked to find how many more seconds for the fan to come into rest with the constant angular acceleration we calculated in task A. Here in task A, to calculate for the angular acceleration, we must first convert our two givens, 500 revs per minute and 200 revs per minute, into revolution per second. To convert into seconds, we must times the 2 with 1 over 60 because we have 60 seconds in a minute. Now we have 8.333 revs per second and 3.333 revs per second. Now we are done converting, we can now plug in our values to our formula, which is final velocity minus initial velocity divided by time to find the angular acceleration. And there you have it. We have calculated the angular acceleration, which is negative 1.25 revs per second square. It is a negative, which means the fan is rotating in a clockwise fashion. In part 2 of task A, we can say that the initial theta is 0. Using the formula, final theta is equals to the initial angular velocity plus 1/2 of the angular acceleration times time square. We can compute how many revolutions were made in the 4-second interval, which is 23.3 revolutions. In task B, we are looking for the time it takes for the fan to come into rest with the constant angular acceleration we computed in task A. To solve for time, we can use the formula final angular velocity is equals to the initial angular velocity plus the angular acceleration times time. We can isolate time by transposing the variables. As a result, we can compute how much more time we need for the fan to come into rest, which is 2.67 seconds. In our second example, we are tasked to find the moment of inertia of a thin uniform rod that is 60 cm long and has a mass of 0.4 kilograms, which has an axis at its center perpendicular to the rod. And what if we bend the thin rod at its center into a V shape with a 60 degrees angle at its vertex? What would be the moment of inertia of this bent rod about an axis perpendicular to the plane of the V at its vertex? In the first question, we can solve for the moment of inertia of the thin rod with the given formula I is equals to 1 over 12 ml square. Plugging in our values, we'll have the value of 0.0120 kilogram meter square. In our second question, by bending the thin rod in half at a 60 degrees angle, we can consider that each leg of the V is half the mass and length of the original rod. Our new mass and length will be 0.200 kilograms and 0.300 meters for both rods. We can compute the moment of inertia of the two rods separately and adding them up as our I total, which gives us the same moment of inertia as the original rod. This is our last example. In this example, we are given the kinetic energy, which is 500 joules, and the angular velocity decreases from 650 revs per minute to 520 revs per minute. We are tasked to find the moment of inertia is required given these conditions. In this problem, the formula kinetic energy is equals to 1/2 I omega square gives us the relation we need to solve for the moment of inertia. We know that the final kinetic energy is less than the initial, which gives us the change of kinetic energy is equals to negative 500 joules. Now we have our relationship in solving the moment of inertia. We must first make sure that we have the same variable units as our given formula. Just like in our first example, we are given revolutions per minute, but the units in our formula is revolution per second, so we will have to convert our values by multiplying the two with 1 over 60 to get the proper values to use in our formula. To be efficient in solving these kind of problems, before plugging in our values, we must first isolate I, the moment of inertia, After doing that, we can now proceed in plugging in our values. We will be able to arrive to the value of 0.00 kilogram meter square as our moment of inertia. That's all for today. Thank you so much for listening. Hope I was able to help. See you next time for more physics solving fun. Now don't forget to like and subscribe. Thank you.